Hey everybody, welcome to this video on the states of matter titled Particles on the Move. In this video, we are going to describe the particle arrangement and behavior of solids, liquids, and gases. So by the end, we will be able to describe the particles of each state of matter as well as the shape of each state of matter. So let's get right to it. This is a diagram of solid particles. You can see that the particles in a solid are packed tightly, and that's because the attraction between them is quite strong. So what they do is they pack themselves tightly into specific geometric patterns. So this one kind of looks like a cube. And you might be wondering if solid particles have any motion, if they move at all. The answer is yes. So let's go ahead and model that. We are going to use our bodies. So you can either stand up if you have room, or you can stay seated. Either way, hold your body really still, but go ahead and hug yourself really tightly, kind of like you're getting cold. And let's say that you are so cold that you start to shiver. So go ahead and pretend to shiver and notice what your body is doing. It's in the exact same position. It did not leave its position, but you have a slight shivering vibration. And that's what solid particles do. They vibrate in place. So what this does is it ensures that solids keep their shape. And for these reasons, we describe solid shapes as definite. Let's go on to liquids. This one is similar. The particles of liquids are close together, but they are not as tightly packed as solid particles, and that's because the attraction between them is weaker. So this gives liquid particles more freedom of motion, and they slide around each other. Let's go ahead and model this one too. Go ahead and make two fists with your hands and touch them to each other. Keep them touching the whole time, but now go ahead and slide them around each other. That's kind of how liquid particles move around. And this gives them flexibility and the ability to change their shape. And we know that it doesn't really matter what kind of container we put liquids in, they always take the shape of their container, and so we describe liquid shapes as indefinite. Last but not least, gas particles. They look really different. You can see that none of them are touching. They are very far apart from each other. That's because the attraction between them is very weak. And this lets gas particles move freely. There are gas particles in the air right now that are flying in every direction, and they're bouncing off the walls, and they're bouncing off of you and me as we speak. We just can't feel them because they're so tiny. And even if they bounce or bump into you or touch each other, bump into each other, they don't stick to one another because the attraction between them is very weak. And so even if you ever observed the steam rising from a tea kettle or your plate of hot food, you can see that the steam, the shape of the steam, which is a gas, doesn't have a specific shape. It's constantly changing, right? The more that it rises, the more that it changes its shape. And for these reasons, we describe gas shapes also as indefinite. So a quick recap, guys. We learned that solids like the chair is an example of a solid, have particles that are packed tightly. There's a strong attraction between them. They can only vibrate in place, and we describe solid shapes as definite. Liquids like this iced tea have particles that can slide around one another because the attraction between them is weaker, and we describe liquid shapes as indefinite. Gases like the wind blowing outside has particles that are very far apart from each other because the attraction between them is very weak, and we also describe gas shapes as indefinite. Thank you for following along, everybody. I hope that you liked the video. Watch out for my next one. Take care.